So finishing up with 6.2, those laws of cosine. So we're going to do a couple problems where we're going to travel, and then we're going to talk about like which direction we're kind of going and finding the distance. Remember when you always heard those like questions, you know, 2 trains, one leaves Chicago and the other one leaves Los Angeles, traveling at this speed and this speed. When do they, you know, collide with each other? So along that lines, but we're going to look at probably like airplanes, and our airplanes are going to fly away from each other, and we're going to figure out the distance because that's a safer way to travel. And then I have another formula for you guys for area of triangles. So there's this guy called Heron, and that old guy, and he came up with this crazy formula to figure out area of triangles, which is kind of pretty cool. So we're going to do that today. Sound like a plan? All right, let me grab this door real quick. So finishing up with 6.2b. Right. Laws of cosine. So, like I said, there was this old guy, so probably about, like 2,000 years ago, there was this guy, Heron of Alexandria, because, back in the day, you got named by, like, where you came from. He derived a formula for the area of triangles. So far, when it comes to, like, area of triangles, we know, like, the area equals 1/2 base times height. Right? We figured that one out. And then we learned another one when it came to cosines. You guys remember that formula? To find the area of triangles. Remember that one? Right? And depending on what information that they ended up giving us. So you could have area equals 1/2, what it was, like BC, times the cosine of A, or which other combination, whatever it is that you needed, or the information that you had. So on this formula, we ended up having, because that base and that height always have to make that 90 degrees, or that perpendicular. So you always had to find that perpendicular. And then when we used this area or law of cosine formula, you had to know 2 sides and you had to know an angle. Right? So what Heron came up with, it was if you knew the 3 sides of a triangle, because back in the day they figured out ways to kind of measure length, but they were still working on how to figure out angles. So if you knew the 3 sides of any triangle, you could find the area of that. So, and it had to do with looking at the perimeter. So where are we at over here? What color we want? Green. So Heron's formula so we got to have some little triangle, and this worked great for those oblique triangles, right? Because we had some side A, side B, and side C. So we had to find the perimeter. And what's perimeter by definition? Perimeter would be the distance all the way around the triangle, right? So the perimeter would be A plus B plus C. So he had to take half of the perimeter, so he came up with a variable S, and S is just 1/2 of the perimeter. So in other words, S equals 1/2 of A plus B plus C. Picking up on what I'm laying down? So when it came to his area formula, we have the square root, and you just had to have half of the perimeter, and then you multiply that by half of the perimeter minus A, half of the perimeter minus B, and half of the perimeter minus C. And then you had to take the square root of it. And technically when you take the square root of any number, you get the positive and the negative. But since we're talking about the area, we're just going to look at the positives, right? Ready to try a cute little example? All think I can leave that guy on there. We're gonna try, right? So let's say we had some oblique triangle, or just any triangle. You can even do this with right triangles. It works with that as well. And let's say we had, I don't know, 12 centimeters, 16 centimeters, and 24 centimeters. And we need to find the area. So, I'm lagging. There you go. So, granted, we could try to use 1/2 base times height. Granted, we don't know right now if it's a right triangle, so we'd have to use the Pythagorean theorem to find out if it was a right triangle. And then if it wasn't a right triangle, and we wanted to drop that little perimeter down, or the altitude down, or that height down, the problem is we only know 3 sides. And in order to sit there and figure out what that height is, you need to know 2 sides, or a side and an angle. And on this 24, we don't know where this splits, because most likely it's not 12 and 12, right? So we don't know what that is, so really we can't even use that theorem. And then, if we were to think of that laws of cosine, when it came to the laws of cosine, we had to know 2 sides and an angle. And we know 2 sides, but we don't know any of the angles. So this is where that Heron's formula comes in handy. Right? So we got the square root of s, s minus a, s minus b, and s minus c. S equals 1/2 the perimeter, right? So S is going to equal 1/2. Perimeter is distance all the way around. So 12 plus 16 plus 24. So S is going to equal 1/2 of 52. So S is going to equal 26. I think I can put this guy up here now. We good so far? You guys are already working through this problem without me, aren't you? So I'm just going to fill in everything, right? So S is 26. So then I'd have 26 minus A. Which one do you want to use for A? 12. Perfect, all right? Times 26 minus B. Which one do you want to use for B? 16, right? And it doesn't matter which ones you put in here, right? 26 minus C is going to be 26 minus 24, right? You just got to make sure you're using all 3 of those sides. So we got what? 26. I'm just going to leave it in parentheses for times, right? Times 26 minus 12 is going to give us 14 times 10 times 2. Multiply all those little guys together. I can't do that one in my head. Use our little handy dandy calculator for that one. And then when we take the square root, we get approximately 85 centimeters. We're on centimeters. Centimeters squared would be our area. Think you guys got those? It's not too shabby, right? So on your formula sheet, your reference sheet, it gives you the formula, but it doesn't tell you what S equals, right? So you have to remember that S equals, what's S equal? Half. Good job, half the perimeter, right? Sound like a plan? All right, ready to go traveling? We're gonna go traveling on airplanes. So I got a long story to write for you. So we got 2 airplanes. Well, 2 airplanes, they're gonna leave an airport. So 2 airplanes leave an airport. Because where else are they gonna leave from, right? And they're gonna leave at the same time. on different routes or on different runways. One flies on a bearing, and we'll talk about what bearing means, on a bearing of north 66 degrees west. And we'll talk about what that means. At 325 miles per hour. And guess what? There's another plane, right? Because we got two planes. So the other plane flies at a bearing of south. Uh-oh, that's not what I wanted. Where's that? South 26 degrees west at 300 miles per hour. So since I'm a math geek, I want to know how far apart they are in 2 hours. So how far apart will the planes be in 2 hours? I think we're good. All right. So first thing is we have some northeast, southwests going on here. Everybody know which way northeast, south, and west is? So remember when you guys used to draw these little guys? This would be north, east, south, and west. How do you remember those? What do? You never eat soggy waffles, right? But to me, any waffle is worth eating, so I think I would eat a soggy waffle, but, right, so never eat soggy waffles. So we have to keep this in mind when it comes to these problems, because that's what that N is. That N is north, west, south, and west, right? And then they're telling us a degree. So this is ultimately saying that you're traveling in a northwest direction, right? This is telling you that it's traveling in a southwest direction, right? So I draw out little pictures on these ones. So our planes are at the same airport, right? So here's like my little airport. And wherever I make my little airport, here, I'm going to label it airport. I'm going to draw that north and south line, right? So this is north and this is south. And I just draw them straight up and down. And our first, ooh, that was crazy. Our first plane is going at a northwest direction. So I'm at the airport and I'm going northwest. I'm going somewhere this way, right? Because this would be west. So I got to go somewhere in between there. So I'm kind of going this way. And at 66 degrees, ooh, so I'm going this way. So that 66 degrees is saying if I was flying due north, I'm then going to go 66 degrees to the west. So that angle right here is what? 66 degrees. We get on where that 66 comes from and gets put in there. So now I'm going to act like my other plane, and I'm going to take off from the airport. And this one's going southwest at 26. So I'm still going to start here at the airport, right? And I should be going like south, but instead of going south, I'm going to go southwest. So I'm going to kind of go this way. And from the south pole, or that south axis, I'm going to go over like 26 degrees, right? So this is going to be the way that I'm traveling. So I'm going to go this way. And my angle that I did not draw to scale is going to be 26 degrees. Uh-oh. Does that make sense? Ish, right? So these planes are going to be traveling for 2 hours in those directions, and we want to figure out the distance between them. How far apart are they? So I want to know how far is it from where he's going to end in 2 hours and where he's going to end in 2 hours. So I'm going to connect those. Right? And when I connect those guys, right, this is what I'm looking for. And what did I make? Starts with a T. A triangle, right? So now we need to see if what we can fill in on our triangle now. So our first plane was traveling at 325 miles per hour, right? So that miles is a distance. So in 1 hour, he's going to travel 325 miles, right? In 2 hours, how far is he going to travel? $650. So then I know that in 2 hours, this side of my triangle is going to be 650. And then my second plane, who's going southwest, how fast was he going? 300. Yep, 300 miles in an hour. So in 2 hours, he's going to go 600. So I know then this guy is 600. So now we just need to figure out we need to figure out an angle in our triangle, right? So I'm going to find this angle right in here. Oops, I did that in the wrong color. We're going to find this angle. So when I drew this line, what do I know about a line? When I add up the degrees of a line, should always be 180, right? So out of this 180 degrees, I know this piece was 66, and I know this piece was 26. So could I figure out that angle? Yeah, just do 180 minus those two angles, right? So 180 minus 66 minus 26 is going to give us 48? 88, yep, 88 degrees, yep. So this little guy is going to be 88 degrees. So if we know the angle in these two sides, you think we can use sines or cosines? Starts with a C. We can use our law of cosines to figure out that one, right? Because the law of cosines was if you knew the angle and like those two sides that made the angle, you could figure out the third side, right? So we're going to go with x squared equals one of our sides, 650 squared, plus the other side. Oh, I'm going to run out of room. I'm going to rewrite this, guys. I think I'm going to put it below. Right. Yeah, x squared equals one of our sides, 650 squared, plus our second side, 300 or 600 squared, minus 2 times 650 times 600 times the cosine of our angle, which was 88. Right? Oh, I'm lagging. We all got fancy dancy, handy dandy little calculators. And then if we take the square root of both sides, we get approximately, what is it, 869 miles apart.